Ladies and gentlemen, it is 8 o'clock, 8:30 in the Netherlands and 3:30 in Japan. Time to start our Netherlands hydrogen supply chain webinar as part of our virtual hydrogen mission to Japan that we organize as Embassy in Tokyo together with the Netherlands Enterprise Agency in the Netherlands. Your hosts today are from the embassy here in Tokyo, me and my two colleagues. On my left, you can see Mariko Nakano, I hope. And on my right, you can see Nicole Dirksen. And I am Rob Stooks, your moderator of today. If you have any questions on technology about this webinar, please mail the address that you can see below Nicole's name. Today's program. After my short opening, we will have 4 presentations. The first is a presentation by combined Vattenfall from the Netherlands and Mitsubishi Power from Japan, followed by a presentation by Netherlands Gasunie. After that, Japanese company Kawasaki Heavy Industries, and finally, Dutch company Vopak. All presenters will be unmuted when they speak. We will operate their PowerPoint and click next slide. So presenters, please, when you have a next slide, just say next slide, please. After the presentations, there will be time for Q&A. If you have questions during the presentations, please use the Q&A function to send us questions. If you do so, please indicate the name of the presenter to whom you want to ask the question. We will close off with a short closing, and I expect to resume this session at about 9:40 in the Netherlands, which is 4:40 in Japan. The first, as an opening, I would like to mention a few things that what we do as the embassy here in Tokyo. The innovation section, we promote and support bilateral relations between Japan and the Netherlands in many fields. And today, of course, the field is hydrogen as part of the energy transition. On the right top, you can see a few booklets of delegations that we organized in the past. The past years, we have organized missions to Japan and from Japan. And these delegations lead to collaboration. And as an example, on the left, you can see a memorandum of cooperation between the governments of Japan and the Netherlands that was signed on September 25 last year. This was during the second hydrogen energy ministerial meeting that was organized in Japan by the Japanese government. In this MOC, you can see on the left bottom that our countries recognize each other as leading countries in this field, and that we need innovation and international collaboration to further this field. The MOC was signed on the Japanese side by Mr. Hideo, who is the Deputy Commissioner of the Agency for Natural Resources and Energy within the Ministry of Economy, Trade and Industry of Japan. And on the Netherlands side, the MOC was signed by Mr. Noor van Hulst, who was our then hydrogen envoy representing the Ministry of Economic Affairs and Climate Policy in the Netherlands. Maybe some, I hope most of you attended the third hydrogen energy ministerial meeting that was organized yesterday, October 14, by the Japanese government. There were many presentations by governments and companies. And here I just summarize a few takeaways that I wanted to share with you in respect to the Netherlands and Japan. Four topics. The first one is that the International Energy Agency presented, and Executive Director Fatih Birol announced that Northern Hulst, who I just mentioned as our previous hydrogen envoy, has now been appointed as a new hydrogen advisor for the IEA. Our Minister for Economic Affairs and Climate Policy, Minister Erik Wiebes, gave a video message in which he mentioned that the Netherlands is strongly stimulating investments and innovation in this field. And also he put the Netherlands on the map as a hydrogen hub and as an important country in the EU backbone. In the industrial session, there were two Netherlands presentations, one from Shell and one from Stedin. And Stedin is also part of our delegation this time. And from the Japanese industry, there were many presentations, very good presentations, including also from Mitsubishi Power and Kawasaki Heavy, who are also here today with us. And I'm really proud that we have this nice webinar with great presentations from important companies leading this field. The whole session of yesterday was recorded, and we will share with you also the link in which you can look back the whole session, including all the videos. So without further ado, I would like to start with the first presentation, which is the one from Vattenfall combined with Mitsubishi Power. Our speaker today is Mr. Geert Laagland, who is the head of engineering of Vattenfall. And I have one request to attendees, as Mr. Laagland has to leave us in about 10 minutes after his presentation. If you have a question to him, use the Q&A function to send it during his presentation, and Mr. Laagland will react to that right after his presentation. If you have questions later on, or also questions related to Mitsubishi specifically, then at the end of our session, the colleagues from Mitsubishi Power, who are also with us, will try to react to that. Having said that, I want to give the word to Mr. Laagland.
Yes, good morning, everyone. Please go to the next slide. Yes, I will talk about our Magnum power plant in the Netherlands to convert it to a super battery. First of all, I want to focus a bit on the reasons why we are considering this. Now, if you go to the next slide, please. Before I go there, I first want to introduce the company as such, Vattenfall. Vattenfall is one of the biggest European energy producers in the field of electricity and heat. We are 100% owned by the Swedish state. Our core markets are in Sweden, in Germany, in the Netherlands, and in the UK. We have in total about 20,000 employees. And one of the main aim of our company at the moment is to help our customers to live fossil-free within one generation. So that's also one of the big drivers for this whole development. If you go to the next slide, please. If we look at this graph, then we see the CO2 emissions developing since 1990 and where we have to go in 2030 and 2050. And if you see what happens until a few years ago, that there was still a decrease in CO2 emissions, that's fine, of course, but we have to accelerate the decrease of CO2. Can you push the button? So we have to achieve a further deep CO2 reduction. We also face a declining domestic gas production, so we will be a gas importer in the end. And we really have to accelerate our CO2 reduction efforts in order to meet the goals in the future. Next slide, please. This is how the electricity mix will change over time. If you look on the left bar, you see in green the current production of wind and solar, and in yellow you see the production by gas, coal and biomass. If you look to the right bar, which is applicable for 2030, you see quite a change. So the share of wind and solar is increasing quite a bit from 15% to 65%. And you see a decrease in the capacity of gas or fossil fueled power generation. We also have some particulars in the Netherlands. It is not allowed to fire coal anymore after 2030. Another element is that if you have this increase in wind and solar, you also have a need for more flexibility in power generation. So gas turbines are a very suitable technology for that. But we also see that if we want to meet the CO2 targets, and we still have to supply about 47 terawatt hours on an annual basis by natural gas, we will not meet our CO2 targets. So we also have to replace the natural gas by another CO2 neutral fuel, like for example, hydrogen or biomass. Next slide, please. If you look at the options to fill in this need for flexible power generations, the options are quite limited. Of course, you can consider biomethane, but biomethane is only limited available. If you look at biomass, there is also restrictions. Of course, you can use biomass from the direct surroundings of the power plant or the country, but there are also discussions on if that's the most wise thing to do with biomass, or that we, for example, should use it for the production of our materials rather than burning it into for power and heat generation. Another option is natural gas with CO2 capture and storage, which is of course possible, but also implies a lock-in on natural gas usage, and one of our main aims is to become fossil-free within one generation. Hydrogen is a good option, but is of course also expensive. Come to that later. Nuclear is disputed heavily in the Netherlands. The discussion is reviving at the moment, but it is not a simple one to implement. And you can also question how flexible this option will be. Fuel cells are still in the development and do not have the skill yet to supply power on a large scale. Next slide, please. So considering those options, our opinion is that hydrogen can play a very important role in filling in this flexible power generation need. It will also provide a long-term value to the Dutch energy system, since hydrogen is not only needed for power production, but it is also needed for industry, transportation, and also high temperature heating applications. So that's why we think, okay, hydrogen, if we do it on a national scale, a national hydrogen backbone, then this provides important options also to use hydrogen in gas turbine plants. Of course, we have some challenges. One of them is the availability of hydrogen. That's not the case yet, that we have large amounts of low carbon hydrogen yet. Hydrogen combustion in combined cycle gas turbines is also not a given yet. There are developments. It's also possible to combust 100% hydrogen in gas turbines, but not in a way that we would like to see. So there's still development needed. And of course, the business case is really challenging because it's more expensive than natural gas. So support schemes are really necessary to make this fly. Next slide, please. So we developed the H2M project. We did it together with Equinor and Gasunie. The Neckan project, it's an existing power plant. It was built by Mitsubishi Power. It was commissioned in 2013. It has a total capacity of over 1,300 megawatt, 3 units, and our aim is to convert 1 unit to low carbon hydrogen. So that is basically blue hydrogen produced from natural gas with carbon capture and storage. and the CO2 will be shipped to Norway and stored in an offshore CO2 storage facility. Mitsubishi Power is our technology partner for that, so they have supplied this power plant, but they also have the hydrogen combustion technology and are also still working on new technology that will be needed for this project. Our main objectives for this project is to kickstart this H2 economy. If you want to build an infrastructure in the Netherlands for hydrogen, then you also need scale. So that's the reason why we want to start with blue hydrogen and in the end change over to green hydrogen, which is produced from excess renewable power supply. The CO2 emission reduction potential is about 2 megatons per year. And as said, we want to gradually change from blue hydrogen to green hydrogen to make it completely fossil free. Next slide, please. Yeah, looking at what we would need from Japan, I think Japan, in my view, is a front runner in the area of hydrogen, introducing hydrogen, building up the hydrogen economy. I think we can learn from that, and yeah, maybe it's also the other way around. But at the moment, I see that Japan is quite ahead of things, so that's really good. If I look to technology, then of course we are interested in electrolyzers, because electrolyzers is really critical to produce green hydrogen on the long term. The skill of electrolyzers need to increase, the specific investment cost for electrolyzers needs to come down, and that's all related to technology development. Technologies for transporting and storing hydrogen is really important. Japan is also working on this with liquefied hydrogen, for example, but also with liquid organic hydrogen carriers. So there's also a lot of technology being developed in Japan, which we can also learn from. And as I said, dry low NOx hydrogen combustion is also really important if we want to introduce it into power and heat generation. One of the examples is the multi-cluster combustor development of Mitsubishi Power. Of course, also if I look to transportation in Japan, hydrogen is also really kicking off there. A lot of technology is being developed, and that will also help the decarbonization in the end. Next slide, please. So this is a nice picture of Magnum. Basically, we have done all the technology studies together with Mitsubishi, amongst others, and basically this plant is ready for hydrogen. The main challenge at the moment is that we want to, yeah, of course, we need a viable business case, and that's depending on support schemes for carbon neutral technologies. That was my presentation. Thank you.
Thank you, Mr. Laagland. Very informative and giving us an overview of the latest point of views and technical standpoints and your questions. I'm looking at written questions. I don't see any at this moment yet from the audience. We, if I may, I do have a personal question in between. Maybe you could give one. Your insight in you talked about the business case in comparison to natural gas. Can you give a timeline in when you would expect such a commercial case, which when it's comparable to natural gas? Do you have an idea on that?
Yeah, that's heavily depending on how the discussions regarding the climate agreement will develop in the Netherlands. Yeah. And when hydrogen for power generation or power and heat generation will be one of the technologies that would be supported, for example, by the SDE++ scheme. Not sure how that what the timeline is for that. Of course, we are discussing that on several levels. But it will take a few years. So at the moment, we expect not that it will be earlier than 2 to 3 years from now that this will be in place. Yeah. But of course, yeah, it's a heavily political debate, so it's also hard to make any firm statements there, because we are very much depending on how this political debate will develop.
Yeah, thank you. I indeed think that on the one hand, we're talking about green hydrogen, and we're developing that. And on the other hand, also what you said about the materials. Now we're not talking about energy only, but the materials. And the third point probably related to also the magnum is that we are reducing natural gas. And how can hydrogen play a role in replacing that factor, that reduction? So what would you, if you have what would you need or expect or request from governments? I mean, not only the Dutch, but more in general, the role of governments in this respect.
If I look to hydrogen in a bigger picture, because similar developments are ongoing in Germany, for example, but also on a European level, hydrogen has a high attention. My feeling is that it is pretty much a chicken and egg situation. If the technology is not there, then there will be no hydrogen economy. Technology is depending on viable business cases, but if the technology not becomes cheaper, is not being developed, then those business cases will also not come. So I think there is a need for some active support to get this going. And I think a consistent view by governments being determined that this should be part of the solution for the future, and also actively support and develop that is really something I could see from the governments. That would be very helpful.
Thank you. I'm looking at the Q&A during the chat function. I actually do not see a question from the audience at this moment. So I propose to go on, and thank you very much, Mr. Laagland, for this presentation and your reactions. And thank you very much.
Yeah, you're most welcome. Thank you.
Thank you. So our next presentation, we go on to Gasunie. And our speaker is Mr. René Schutte, who's the program manager of hydrogen in Gasunie. Mr. Schutte, the virtual floor is yours.
Thank you, Mr. Stroeks. Welcome to you all to attend this webinar. I'm going to try to tell you something about the hydrogen supply chain, and then especially related to the Netherlands. Maybe starting with something about Gasunie on the next slide, please. Gasunie is a European infrastructure company. We have gas grids in the Netherlands and in Germany, part of Germany, and also other gas assets in the receiving terminal and gas storage, for instance. We are a state-owned company. The Dutch government owns the shares of Gasunie, and the key of our business is that we provide open access assets and services to our customers. Next slide, please. We have several strategic routes, and one of them in the sustainable environment is looking at what's going through our grid in future and going through our assets in future, where we basically see green gas being an option for future transport, heat networks. We also look at CO2 capture and storage, and not the least to hydrogen. So this combined is what is on our agenda at this moment in time to help accelerate the energy transition towards 2050. Next slide, please. Just to start with the hot summer we just had, the strategic hot summer, where you saw that Japan already came with hydrogen vision and strategy in 2017, so almost 3 years ago. And this summer it was picked up by many countries, and some of the countries have their strategy in preparation, meaning that hydrogen has become top of the agenda as people recognize more and more that this is a missing key element of the energy transition. Next slide, please. And what it's all about. This is basically the landscape of why we are looking into hydrogen. On the left bottom, you see the picture of the current energy flows through the Netherlands, whereas electricity is only 20% of the energy used. Gas and oil take 80% as molecules, of which gas is 40%. But what you can see on the blue line, which is the gas line, is that all the flexibility, so the difference between demand and supply, is covered by gas. So that's a key function that needs to be replaced in future in another system, and hydrogen can do that. If you look at the top right, you see the renewable energy, the daily electrical production and load profiles, where you actually see what the increasing problem is with renewable energy, that it's not as stable in production as we are used to with, for instance, power plants. That means that we need to cater for another volatility of the renewable energy production. Meaning that it's not only the flexibility that we know today, but also the flexibility that will increase in future that we need to cater for. Hydrogen can do this. Hydrogen can be transported about 10 to 20 times cheaper compared to electricity. And storage of hydrogen, which can be done in caverns, can take about 1,000 times cheaper as storing the energy in, for instance, batteries. Next picture, please. For the climate agreement, we made an assessment to the demand scenarios, which are the 3 lines you see on this graph, versus how do we need to fill those lines with production. What you see is that currently we already have a high usage of hydrogen in the Netherlands, and that's predominantly for feedstock. So we talk a lot about hydrogen for energy, but hydrogen for feedstock is the core element at this moment in time for the hydrogen production, transport, and usage. We see an increase of the need for hydrogen, dependent, of course, on several scenarios, which have to do with time and the time that systems can be built. But determined into the colors, until 2030, a lot still will be done with fossil fuels, with and without carbon capture, which is the blue part. And the green part is what we intend to build for green hydrogen. The aim from the Dutch climate agreement and also the hydrogen vision of the cabinet of the government is 500 megawatt in 2025 till 4 gigawatt in 2030. And for this, you need to understand that 4 gigawatts also means 4 gigawatts of renewable power. So, for instance, 4 gigawatts of installed power for wind at sea, wind at land, or solar power, which is also a challenge in itself. To have that installed by 2030, which would be about 1/3 of the planned renewable energy sources in the coming decade. Please, next picture. And the key elements that we need to build up this hydrogen market is infrastructure. To bring demand and supply together, and also to connect it to storage. On the very left part, you see a pipeline which is 12 kilometers located in the south west of the Netherlands, which we converted 2 years ago from natural gas transport to hydrogen transport, just to learn and understand how that would work. And in principle, the conclusion is that we can use our existing natural gas grid to transport hydrogen in future. On the Highway 27, together with the government, we are doing a study to determine what is required in technical and safety way, but also in business case and law and regulation and demand and supply to basically face the construction of this infrastructure in the current decade. Together with infrastructure companies all around Europe, we made a map of how this infrastructure can be built from existing gas grids into a wide European net by 2040, meaning that with that we can connect all demand and supply locations with existing infrastructure, and of course with storage that we have at several places in the Netherlands. Please, next picture. And this is the plan that we're investigating, studying at this moment in time, and that we want to build in phases. This is about an 1100 kilometer pipeline, which is predominantly existing infrastructure, which is the yellow part. The blue part is some new pipeline that we need, because obviously we still have a lot of natural gas transport in the Netherlands. And with this, we can connect the 5 main industrial clusters in the Netherlands, where we believe that the main demand increase from hydrogen will come from industry for starters, followed by mobility, maritime, and later households. We can connect this to storage on the eastern border between Netherlands and Germany. There's, let's say, a large salt mountain underground, where a lot of caverns can be made, and a lot of caverns already exist, but now are used for natural gas storage. We also look at import of hydrogen, because we believe that only part of the hydrogen that we need in future can be produced in the Netherlands. Which also look at reaching the site. Next picture, please. And this together is the map of projects that Gasunie is involved in the Netherlands. And this is what is required to build up that infrastructure, because the infrastructure itself will only be built if customers have need for the infrastructure. And that means that we also need to help develop the production of hydrogen. And we need to help develop the demand for hydrogen. So building the full supply chain, because without the value chain, we don't need infrastructure, and all the projects will not come to life as well. One of the projects I want to show, and that's on the next page. And that's basically the concept of the full value chain, where we are together with Groningen Seaport and Shell, developing the full supply chain coming from above the Netherlands wind at sea, which is converted to hydrogen onshore, then transported via the grid that we need to construct to the main industrial areas, not only in the Netherlands, but also in Germany and in Belgium. Where we have opportunity for international connection. This is aiming at the climate agreement targets of 500 megawatt in 25, 4 gigawatt in 2030, and 10 plus gigawatts in 2040. And with this, it's not the 3 parties that are going to build this. With this, we aim to invite all parties alongside the value chain to help take their part of the value chain, not only in the production, in the installation of wind at sea, but also in the demand at several industrial areas. Next slide, please. And this is one of the international cooperations we have together with Belgium and Germany to build that full value chain. This is part of the Hydrogen for Climate Action, which is a program run by European Commission, which is leading towards the IPCEI application. You already asked for the instruments that are needed. In Europe, the different member states are looking into IPCEI which should help to relax the state aid rules and try to give support to the development of the full energy system, because part of the energy system that needs to be built here, but it's a full energy system. And that goes with a lot of new risks, for instance, and governmental support together with investments of industries are required to build this together. And then the next slide, please. And this is one of the campaigns I would like to show, which is combined to Japan, which is using the Olympics, which unfortunately didn't happen this year, but was already planned for this year, that we teamed up with the Dutch Olympic Committee to also make public awareness of hydrogen and what's needed for that, to use a flagship around the water sports events to demonstrate hydrogen and to show the public what hydrogen is, and to get used to this for future. And this is where I want to leave it.
Thank you, Mr. Schutte. Very interesting and informative presentation. Different from the previous presentation, we will continue with the next presentation and leave the questions to the end. So with thank you very much for your presentation, Mr. Schutte, again, and we will go on to the next presentation. Which is by is by Kawasaki Heavy Industries, Mr. Hideo Shigekiyo. Mr. Shigekiyo is a principal researcher and business development section within the Hydrogen Project Development Center within Kawasaki Heavy Industries. And Mr. Shigekiyo, I give you the virtual floor now.
Okay. Thank you, and good afternoon, everyone. And thank you for the opportunity to give a presentation. I'm Hideo Shigekiyo from Kawasaki Heavy Industries. Today, we would like to introduce our Kawasaki recent activity on hydrogen infrastructure. The title is International Liquefied Hydrogen Energy Supply Chain. The next slide, please. Next slide, please. Okay. Before my presentation, allow me to introduce our company briefly. Kawasaki was founded in 1878 and had about 36,000 employees. Business interests include shipping, build and marine engineering, rolling stock, aerospace, environmental control and engineering, plant engineering, power plant engineering and steel structure, motorcycle and personal watercraft, machinery and robotics. The hydrogen supply chain and related technology have been developed by the Corporation Technology Division we belong, in close cooperation with this business division. By applying such a technology, we have been developing products that are necessary for realization of hydrogen energy supply chain. The next slide, please. Okay, return to today's presentation. This slide shows about potential CO2-free hydrogen supply chain to Japan. Currently, we have been promoting CO2-free hydrogen supply chain worldwide. As shown this, we are looking for a suitable place to supply a cheaper hydrogen produced from renewable energy such as the solar, wind, or hydropower other than fossil fuel. In the near future, we expect that CO2 free hydrogen from renewable energy will be able to supply to Japan in large quantity and low cost. However, now renewable energy cost is still expensive, high cost to produce hydrogen. Additionally, it is difficult to produce a large amount of hydrogen. So our group decided to demonstrate a pilot chain by focusing on Australian brown coal with CCS, because it is a large amount, suitable supply, and cheaper. The next slide, please. This slide shows about the concept of international liquefied hydrogen supply chain. We will produce hydrogen at overseas from affordable resources such as renewable energy or unused resources. Even if using a fossil fuel, by using a CCS technology, we can produce CO2-free hydrogen without almost atmospheric CO2 emission. After then, we bring to Japan as a home of liquefied hydrogen. Finally, we will use hydrogen in various fields. We believe this large-scale supply chain will accelerate the realization of decarbonization and sustainable future. The next slide, please. Okay, next is about our hydrogen technology. To realize a full liquefied hydrogen supply chain, our Kawasaki has developed various cutting-edge liquefied hydrogen products. In production, we have already succeeded to develop a liquefier for the first time as a Japanese company. In storage, Kawasaki has provided a number of liquefier hydrogen tanks and containers to the market since 1970. For instance, in the Australian demonstration project, we have almost constructed a 1,250 cubic meter storage tank for carrier and 2,500 cubic meter tank at the loading base. Due to transport a large amount of hydrogen over the sea, we have constructed a world-first liquefied hydrogen carrier. In order to reduce the cost of hydrogen, it is necessary to consume a large amount of hydrogen. Therefore, Kawasaki has developed a hydrogen-fired gas turbine cogeneration system in Kobe area. It is a very effective system for hydrogen consumption and cost reduction. The next page, please. To realize the commercial supply chain, we have been conducting the pilot demonstration project between Australia and Japan since FY 2015. This is about pilot demonstration structure of liquefied hydrogen supply chain. In this demonstration, there are two portions. One is the NED portion and another is Australia portion. The scope of NED portion belongs to gasification in Australia, hydrogen carrier, and unloading terminal in Japan. On the other hand, Australia's scope is gas refining, liquefaction, and export loading terminal in Australia. We are working on this project in collaboration with our partners with the support of each country's government. The next page, please. At the end of FY 2020, we will supply liquefied hydrogen from Australia as a pilot demonstration. The upper pictures are Australian bases. They are constructing on schedule. The lower left picture is about the construction status of liquefied hydrogen carrier ship. Last December 2019, we held the launching ceremony of this carrier ship in our Kobe factory. Its name is Frontier. The carrier is currently outfitting and will be completed soon. The lower right picture liquefied hydrogen loading base in Kobe Airport Island. Almost equipment and tanks have been completed. The next page, please. The next about the demonstration for hydrogen utilization. This slide shows about our hydrogen CGS demonstration conducted in Kobe City. CGS means cogeneration system. It's the world first to supply electricity and heat by burning 100% hydrogen in a gas turbine in an urban area. This project carried out from November 2015 to February 2019. Recently, Kawasaki has announced that a new dry, low NOx hydrogen gas turbine system developed too. The technology verification test started in May this year and was the first successful in the world. The dry combustion method has higher power generation efficiency than the conventional wet type method and can reduce NOx emissions. The next page, please. Final page in here. We would like to ask the Netherlands for several matters. For the first request, our Kawasaki have been developing a state-of-the-art hydrogen-related products, and in the near future, we plan to sell these products all over the world. At that time, we would like to recommend our production to Netherlands and European companies who are interested in our products. We not only provide products, but also support EPC jobs at required hydrogen loading terminal, based on our experience. The second request, we would like to ask for your cooperation so that we can participate in hydrogen-related feasibility studies and demonstration projects currently under consideration in the Netherlands and Europe. Especially if you have a liquefied hydrogen plant, including the liquefaction, storage, marine transportation, please recommend it to us. The final page, please. This is the end of my presentation. Thank you so much for your attention. Thank you.
Thank you very much, Shigekiyo-san, for again a great presentation, similar to the previous ones, very informative and really the latest standpoint that you have. I would like to go on to the next presentation, which is by Royal Vopak. And our presenter will be Mr. Hans de Willigen, who is Business Development Manager, New Energies in Vopak. Mr. de Willigen, the virtual floor is yours.
Thank you very much, Rob, and very nice to connect to you all and giving me the opportunity to talk to this audience. In the next next 10 minutes, I will shed a light on Vopak's developments on new energies and hydrogen specifically. If you can go to the next slide, please. Maybe just a small introduction to who Royal Vopak is. We are a publicly listed company in the Amsterdam Stock Exchange. We exist for over 400 years already. We started in the East Indian Company trade of spices, herbs, and coffee from the East. Today we are stock listed, as I said. We are operating global tank terminal network of around 66 terminals in the world, in over 23 countries. with a total storage capacity of more than 34 million cubic meters of capacity, ranging from oil to chemicals, biofuels to LNG. And we will talk about it later. Of course, now also focusing on the potential opportunities in the new energy space. Next slide, please. Yeah, who is Royal Vopak? What is our meaning to our societies at large? Royal Vopak has a statement which is called "Storing Vital Products with Care," meaning that we want to really play a role in supporting the world and its population with vital products, and connecting supply and demand areas for energy products, for food products and chemicals, which are needed around the world, whereby the population is of course growing, and whereby our network is continuously adapted to the global new developing supply chains around the world. And we do that with utmost care. Our first and foremost priority is that we want to ensure safe, efficient and clean storage and handling of these vital products in our network of terminals. And we have that as our prime target to be as safe as possible in all the products and handling of operations as possible. Next slide, please. Just a nutshell how Vopak operates. We are, as I said, operating global tank terminal operations around the world, but we do that in an independent fashion. We never own the product that we store, so we store the products in our tanks for our customers. It also means that we do not compete with any of our customers, and that we are truly open access for multiple customers and multiple products in our network. It also means the independent position that our shareholders are not related or involved in the chemical, oil or energy markets at large. And by our presence on the Amsterdam Stock Exchange, we are transparent in our reporting. You can read all that on our website, vopak.com. And through the way we operate our facilities is basically open access. So we try to combine products, volumes, customers in an open access fashion, such that we reach economies of scale in developing these supply chains. Next slide, please. With our tank terminals, we are truly an integral part of the value chain, supply chains that we see on a global level. And from left to right, you see basically locations where feedstocks are produced or are explored. You see that those are exported to other destinations, often larger demand centers. And in between the transportation and the end destination, there are tank terminals required for export or import in those production and destination locations. And through our network of terminals, we facilitate an important part in this value chain of our clients. Next slide, please. Yeah, then looking at the global energy transition, we believe that there is several pathways in this transition. Not all the regions around the world have the same meaning of notion about energy transition. We basically divide it into three sectors. First and foremost, I think ending energy poverty. There is still a huge requirement to get access to electricity or clean cooking, for example, for a lot of people around the world in many regions. So that's an important element of the transition. The second one, of course, has to do with providing clean air in locations where there is a very strong need to reduce harmful emissions. And the last, but certainly not the least one, is combating climate change. The agreements in the Paris Climate Agreement and the regional or local ambitions are leading towards a significant CO2 emission reduction. And we think that through the energy transition and our role in that, we can play an important part in that ambition. Next slide, please. So what would be our role in this energy transition? Well, we have, as I said, leading port assets around the world, where we can really facilitate import and exports from locations where there is energy or supplies available to regions where there is a demand of those key products. We have a good network of these independent locations, and the know-how in how to operate these assets and connect supply and demand is there already for quite some time, as I said, for over 400 years. And the role we can play towards our clients is to really develop these global supply chains with the deep market knowledge that we have established across the value chains and across the energy products. Next slide, please. And we basically concentrate at the moment in the energy transition on 4 key sectors and a role that Vopak can play in those sectors. The first one is the developments on the flow batteries side, whereby our tank terminals can basically act as large batteries in the tanks that we operate in our key ports. And the main purpose for that is really to balance the supply and demand, which are changing overnight and over day and during the season through the capacities on flow battery storage. The largest one at the moment we are focusing on is hydrogen logistics. I'll come to that later after this slide. We also involved in projects which involve the storage of carbon dioxide and the reuse of carbon dioxide in, for example, renewable fuels or reuse in chemical production. And we are currently involved in quite some projects to get storage and shipping for carbon dioxide organized in our region. And the fourth one has to do with green feedstocks, new feedstocks, and recycling of plastics, for example, and to reuse those again to become more circular in the use of those feedstocks for the chemicals, plastics, construction industry, as such. So 4 key focus areas, and I'll now turn to hydrogen on the next slide, please. Yeah, we as Vopak are currently involved in 3 types of technologies that we think all have a place in the years to come when it comes to building supply chains for hydrogen. Liquid hydrogen, I think an excellent presentation from Kawasaki Heavy Industries. And we also want to learn from that and particularly because we think that liquid hydrogen eventually in a large scale can become a very competitive and meaningful way of transporting hydrogen globally. There are some challenges and some development areas, I think, to bring it really up to large scale. And that, of course, is the cooling technology to in a large scale liquefy hydrogen at the very low temperature. And of course, the significant investments that are related to that, not only on the tank storage side, but also on the shipping and regasification part and liquefaction. But it's similar to LNG or analog to LNG. We operate LNG terminals already around the world. We think we can derive some knowledge on that and apply that to building liquid hydrogen supply chains going forward. The second one has the liquid organic hydrogen carrier technology as a technology to transport molecules of hydrogen while being connected in a carrier material. We are working towards several projects and pilots in our region and also more and more in the East. The one big advantage of LOHC technology is the use of existing infrastructure and the safe and easy way we can handle it. And I think some challenges has to do with energy efficiencies in the LOHC technology and reactor upscaling of that. And I think end markets are typically focused today on mobility and heavy industries. Later on, while achieving economies of scale, this can also be used, the LOHC technology, for larger industry use. And the third one, of course, is ammonia, a very interesting means of transporting hydrogen. You can use existing LPG infrastructure, and yeah, some challenges I would say are to do with the chemical capabilities and competencies of the product, which need to be overcome to make it a very meaningful, large-scale way of transporting hydrogen. Next slide, please. As I said, Vopak believes in all the three carrier technologies, and we have quite some analysis done already to build the most efficient supply chains for all the three technologies. I think a lot of choices in the technology of the three technologies has to do with the end market, which will determine the technology to a large extent. And next slide, please. And what we are currently doing and have built, now the previous one, please. Yeah, thanks. What we have done is to build both supply chain modeling and financial modeling systems to optimize the full supply chain, and depending on the technology, come to the right conclusion per supply chain development. So each supply chain has a specific typical value chain development and pricing mechanism in place, with which I think through our modeling we can define the best technology to be used. And of course, we are more than willing to help the Japanese clients and counterparts and stakeholders with this technology going forward. Next slide, please. Yeah, this is just illustrative because we are working on many projects around the world, but I think it was indicated in the previous presentation. Clearly, supply and demand are not particularly on the same place. So countries and areas with abundant solar and wind energy can support the larger demand centers. And with our global network and global presence, we are connected to those developments in current project development. And that is a very encouraging time frame we are in. So we are involved around the world, and please connect to us if we can be of help also in your region. Next slide, please. Yeah, this is then, I think, the final slide to say that we, through our tank terminals, can really facilitate export, but certainly also on the import side, and become a hub location for any distribution onwards towards industry, road distribution, reshipping, redistribution on fueling stations, and also, of course, to integrate with the local industry and supply them with hydrogen from our terminals. And the last slide, I think, is the next slide. Basically summarizing all this, we think the momentum is growing. There's a strong supply side push from areas with abundant resources. There is also a demand pool whereby mobility is expected to be the first sector where hydrogen can pick up in the shorter term. And Vopak's ambition is to really lead import locations around the world for all the technologies, both liquid as well as ammonia and liquid aquatic hydrogen carrier. And I think we are very well positioned to help the market moving forward. With that, I would like to leave it. And thank you very much for your attention, and have a nice day.
Thank you very much, Mr. de Willigen. Very good overview of Vopak's activities at this moment. Thank you very much. This concludes the 4 presentations that we have prepared for you today, together with the speakers. I look at the Q&A function in our WebEx. I see a question and a few questions. And maybe if you allow me, I ask them to have maybe one for each presenter. Maybe just to begin with the first presentation, which was by Vattenfall and Mitsubishi. Geert Laagland had to leave us already, but we have Mitsubishi Power, Mr. Ichishiba, with us. And I just had one question for Mr. Ichishiba. If you could for Mitsubishi Power, you have this collaboration with Vattenfall. How important is that for Mitsubishi's future domestic hydrogen business in Japan? So how can you use the collaboration with Vattenfall also in the future in Japan? Could you elaborate a little bit on that or react on that?
Yes, can you hear me?
Yes.
Okay. The answer to this question, our feeling in the market is the Netherlands is a bit ahead in the world for this actual project. And the target is maybe middle of 2020 to start hydrogen firing. So if we success this project, for sure we can use the same technology. We can apply same technology in Japan when Japan is ready for using hydrogen in the power generation. That's my reply to this question. Am I answering this?
Thank you very much, Ichishiro-san. I have here also a question for Gasunie, Mr. Schutte. I have a question about Gasunie's role in the area of blue hydrogen and the role that you play in collecting the CO2 and how to transport and the transportation pipelines to transport that CO2 probably back to Norway in that sense, I think. And the question is from Alex Ruiter from Saditech. Thank you very much for this question.
Thank you for the question. Yes, already Vattenfall had presented a project on blue hydrogen where we are also involved in. So I left this out of the presentation indeed. But we are involved in the dedicated CCS projects. Mentioned Atos and Portos in Netherlands, where we look at transport of CO2 after it's being captured, of course, at the site. Transport of CO2 into former oil or gas fields. These projects are currently in detailed engineering study. So we're really heading towards commissioning this in the next couple of years. Together with Vattenfall and Equinor, we look at the chain towards Norway in combination with Northern Lights, where we want to capture the CO2 in the Netherlands and then ship it back to Norway and then store it on the ground. So yes, we are involved in this part of the value chain. We should not forget that hydrogen is all about CO2 capturing and reducing the emission. So the earlier we can do that, the better it's for the climate. And it can help accelerate the energy transition in the coming years for sure.
Thank you very much, Mr. Schutte. I also have a question for Shigekiyo-san. If you could elaborate a little bit. The international supply chain that we had, the topic of today, is a very key part of the development of hydrogen. And I would like to ask you, so this is not a question from the audience, but it's a question from me, if you allow me. How do you see the role of the Netherlands in this respect? And if you could zoom in on any aspects of the following. If you talk about the cost of hydrogen, if you talk about different the carrier systems that you have been explaining, the liquefied hydrogen carrier systems, and maybe if you look at the future, now this project is going on, which is a demonstration and project, but how could you see a next step in this project, and what kind of role for the Netherlands would you foresee there? If you have a reaction on that, please.
Okay, thank you for a good question. Regarding the hydrogen cost, before conducting this part demonstration, we have already done feasibility study regarding the hydrogen cost. According to this study, total cost will be 29.7 Japanese yen per normal cubic meter in CIF condition base. In the breakdown of the cost, liquefaction cost was the most expensive. As you know, 9.7 Japanese yen per normal cubic meters. CCS cost was 2.1 Japanese yen per normal cubic meters. We expect that the cost of hydrogen will be even lower if a large amount of hydrogen will be used more in the future. Additionally, regarding the power generation cost, according to the forecast by METI, power generation cost by hydrogen resource will be 16 Japanese yen per kilowatt hour at 2030. And in 2050 will be 11 Japanese yen per kilowatt hour. In 2030, this hydrogen cost will be more expensive than LNG, but we believe that it becomes reasonable cost in 2030, I think. Thank you.
Thank you very much, Shigekiyo-san. Mr. De Willigen from Vopak, also you are active in the international supply chain area, and for 400 years already, very impressive, going always on high value goods from spices and coffee to energy. So that's you're always on the forefront of what is active at this actual at this moment. And I was also wondering here, actually the other way around. If you look at Japan and also, but maybe zoom a little bit in, because supply chain, we are talking about international supply chains, and roles of governments are very important. This public-private collaboration. So what is your view on how do you view the role of the Japanese government in supporting these international supply chains that are so important for this geopolitical future that we are talking about? If you have an opinion on that, as far as you can tell, as far as you know.
Yeah, I can probably give a bit broader answer. I think there is so much technology knowledge in our Japanese counterparts and stakeholders, that I think that technology knowledge and the experience that is present in global supply chains and developing that technology around the world can be a good ground for cooperation between the Japanese companies and Vopak. As I said, one of the technologies that we look at is LOHC. Shiyoda in Japan is a very key producer of that technology and currently also scaling up the technology. So we strongly believe in that sense in the technology and the know-how which is present. And I think combining that know-how and spread that around the world in cooperation with companies in the Netherlands would be an excellent meaning, I think, to go forward. And I think on the governmental level, on the country and diplomatic level, I think the countries are very well connected already for a very long time, and I think we should continue to use that big friendship and develop that along the lines with the practical business and technology sense that we have on both sides. Thank you.
Thank you for a great answer. I don't see any other questions from the audience. I do have seen some really nice, so you're also connected together. I will not ask you to ask questions to each other. We will connect in another event, if you allow me. And also I'm looking a bit at the time. I would like to give a few, what for me, I thought the presentation and discussions are really very informative and learnful. I had written down a few takeaways, which I would like to share with you, which is not on any official closing for me or contents, but what for me, I think what I learn here is, or we could recognize again, what we learn here is that the hydrogen, if you talk about the supply chain, is expected to go and play a really large impact on the international energy supply system. So what is the impact on that? It's very important to look at the global political arena in this sense. So these balances between governments and companies. We've been talking about what the ways on these supply chains, the technological ways to transport these issues, and here we need strong collaboration between public and private sector, and also international collaboration. And in our case today, we're talking about this bilateral relations. So I think we saw a lot of opportunities for further discussion between Japan and the Netherlands in this respect. What I also think is that there were quite some we have quite some, let's call them dilemmas, but also challenges and hurdles. We are going from gray to blue to green. So how are those developments connected? We talk about long-term goals and short-term activities or actions that we need to make. How do they connect? We talk about large-scale developments, and we talk about maybe also smaller scale developments. So how to combine bigger and smaller. And of course, we heard the chicken and eggs example: supply and use. There is no supply without use, and no use without supply, of course. But this is, and today we talk about supply, and tomorrow we will have a webinar on the use in a smart city environment. And the next week, Monday, we will have a webinar on hydrogen policies. So before going on, there's a little advertisement or two for you all to also join those webinars. And I think what we need, if we talk about Japanese-Netherlands collaboration, that today we had 4 great companies and opportunities to collaborate. And I think in order to develop bilateral collaboration, we also need an environment in which this development, this collaboration can be fruitful. So helping not only 2 companies to come together, but also shaping this environment in which this collaboration can take place. I think there is a very important role for governments, but I think also for embassies to assist you in that. So if you have any further needs for assistance on broadening the environment and the networks in which you collaborate, then that's always, you can always contact us. And only in this way, if we work together on all these issues that I mentioned, I think that we can come to a real substantial and a sustainable role of hydrogen in the energy transition. But it's not only the energy transitions, because we're also talking about challenges for resources itself and about the air and climate changes, etc. So it is a much more at stake than only energy as such, but also from start to end on all the issues and impacts that it has on chemistry, on materials, etc. So I think this is not an easy topic. It's connected to a lot of aspects, and therefore I think it's necessary and very fruitful that we talk together and understand each other and can help each other in this sense. So with having said that, I look at Nicole. We have another question. Is that correct?
It is an administrative message from the organization that the next session for the Dutch participants will start at 10:30.
Yes. Okay. So that was, I hope everybody could hear that. There will be a next session in half an hour, but if for all the participants, for the Dutch participants, look at the platform, but this you still have time, I think, for that. Correct? Yes, it's correct. So with having said that, I think I would really want to thank the 4 speakers, and also Shigekiyo-san from Mitsubishi Power. He didn't give a presentation, but thanks for the reaction. And if there are more questions, do not hesitate to send us from audience or from presenters, and we can connect you to any other person that you would like to speak to in this respect. Again, tomorrow there will be a webinar on smart cities. So this is on the use of hydrogen in mostly actually in built environments or buildings. And next week, Monday, we have a webinar on government policies with Dutch government, which Dutch Ministry of Economic Affairs, Japanese MITI, Dutch TKI and New Gas. We have and some local governments, municipalities of Groningen, Rotterdam, and the Japanese city of Kawasaki. So not Kawasaki Heavy, but Kawasaki City. So we have quite some interesting speeches as well. And if you're interested, all you're invited to listen in that as well. Having said that, again, thank you very much, speakers, for your great contributions, and thank you, audience, for listening in. And if you have any further questions, do not hesitate to contact us. Thank you very much. And with that, there is no final question anymore. I would like to close this session, and thank you very much.